now we will look at operations with functions. So just as we would with regular numbers, we can actually look at dealing with operations on functions themselves. We can add functions and we get a function output. Subtract functions, we end up with a function output. Multiply functions and divide functions. We could also talk about the domain and ranges of these. I personally am not going to test you on that, but one way to think of the domain actually of all of the operations of the functions would just be the intersection of the domain of the f of x and the g of x. So the intersection of those, if there's any restrictions, you toss them out. But it also, with the division, you also have to exclude values where it makes the denominator go to 0, just for the reason of undefined values. So basically, it's exactly what you'd think if you have f plus g of x function. The addition function is going to be f of x plus g of x, and it's going to be similar to some other earlier algebra you've done in the past. So this is example number 3, A through F of the Chapter 12 practice test. If I'm given a couple of examples like f of x equals x squared minus 1 and g of x equals 3x plus 2, and I want to find the following, basically I'll take if I asked you to find f of negative 2, so you just replace your x with negative 2. That's just checking function notation, how to deal with that. So I just plug in negative 2 and square it. Make sure you use parentheses around that because the x is being squared. So I end up with a 4 minus 1, which is just going to be 3. So f of negative 2 is equal to 3. If I asked you to find g of x plus h, this is really going to emphasize the input or the outer shell concept of input-output. When g of whatever is actually equal to 3 times whatever plus 2, so g of x equals 3x plus 2. So g of whatever is going to equal 3 times that whatever plus 2, and so instead of putting x, you replace x with x plus h, and then simplify it. So g of x plus h equals 3x plus 3h plus 2. Now we'll get into the operations. If I asked you to find f plus g of the general case x, it's really the same thing as saying f of x plus g of x. So you just add your functions together, combine your like terms, and you get f plus g of x equals x squared plus 3x plus 1. Subtracting is the same as adding, but you have to distribute your negative through to the g of x. So it'd just be f of x minus g of x. And so I distribute my negative through, combine my like terms, and I should get, this actually should be f minus g of x equals x squared minus 3x minus 3. And then if I look at something like E, if I have f times, I would just multiply f of x times g of x. So you use your distributive property and combine your like terms if there is any. There isn't actually in this case, and you should end up with the 3x cubed plus 2x squared minus 3x minus 2 in this example. And then dividing, but I'm not actually asking you to find f divided by g of negative 1. I'm actually asking you to find, of x, I'm actually find of negative 1. So you could say f of g of negative 1 is actually the same thing as saying f of negative 1 divided by g of negative 1. And you just plug in negative 1 into your f, find the answer, and you get 0. Negative 1 to your g, find the answer, and you get negative 1. 0 divided by negative 1 is just going to be 0. And so that's how we can find operations, deal with our operations on our functions. The next now we'll look at is composition of functions, where we'll actually put functions within functions. So